Student, in this video we are looking at the multiplication of matrices. So how do we really multiply matrices? We multiply a row, an entire row, by an entire column to produce a single value. So if I'm given a 2 by 2 matrix, when I say 2 by 2, that is the order of the matrix is 2 by 2. So if I have a 2 by 2 matrix, let it be arbitrary P that is equal to a 2 by 2, its order is 2 by 2. So if it is A, B, C, D, then I have there a matrix Q, maybe which is E, F, G, H, and then I'm told to produce PQ, to multiply matrix P by Q. And remember, student, PQ is not the same as QP. Yeah, so PQ, it means give me P, which is A, B, C, D, then I'm multiplying it by Q, E, F, G, H, such that we are multiplying row by column. Our principle of row by column still holds here. So row by column, row by column. I'm going to have A times this, so it is A times E, then plus, it is row by column, so plus B times G. Then to produce the digit here, I come to the lower row times this first column, so I have C times E plus D times G. You can put some small brackets for these guys to show that we are adding at the same time multiplying. To produce the next digit here, I get the first times the last, so I have this as A times F, A times F, A times F plus B times H. Then the next one, I have there the last row times the last column, C times F plus D times H, such that I have this as AE plus BG, CE plus DG. Then I have AF plus BH, CF plus DH as that is the general principle underlying all matrix multiplication. That is the general principle that underlies all matrix multiplication. Yeah, so then we can look at an example. Yeah, so our example, we have M and N. So they want us to compute Mn. So as part of our solution, our matrix Mn, this will equal to M first, 0, 1, 3, 0, 0, 1, 3, 0. Then we are multiplying it by N, which is 2, 1, 3, 2. And then, student, what you should know is we are showing the multiplication. Don't multiply by head and put the answer at once. So endeavor to show the multiplication. So we have there row by column. This is going to be a 0 times 2 plus a 1 times 3. You can put some simple brackets to produce the digit here, the last times the first, the side. So I have 3 times 2 plus 0 by 3. Then to produce the next digit here, this times the last column, 0 times 1 plus a 1 times 2. Then the very last, the last times the very last. So I have a 3 by 1 plus a 0 by 2, such that if we move to the next page, so we have there a 0 times 2, so this will equal to a 0 times 2. We have here a 0 times 2, which is a 0, then 1 times 3, which is a 3. So we have here 0 plus, hope you are trying to follow, 0 plus 3. Then we have here a 6 plus 0. Then we have a 0 plus 2. Then we have a 3 plus 0. So this was a very simple one, such that we have a 3, a 6, a 2, and a 3. Yeah, so it is I think as simple as that. So our Roman numeral 2, this one was Roman numeral 1, this was Roman numeral 1, such that our Roman numeral 2, we want n squared. So student, we have our matrix n as equal to a 2 1 3 1. N squared does not mean I come and I square just these elements here. No, just don't come and square the components of n, but n squared means matrix n multiplied by itself. As simple as that. So I have here 2 1 3 1 multiplied by itself, which is 2 1 3 1. So we again go row by column. So this is going to be 2 by 2 plus 1 by 3. Then row by column, this is 3 by 2 plus 1 by 3. Row by column, I have there 2 by 1 plus 1 by 1. Then row by column, this is 3 by 1 plus 1 by 1. Such that if I try to show that I'm multiplying, so I put brackets, then don't forget to put there the matrix. Yeah, most people forget putting there the matrix, but endeavor to put there the matrix because we are dealing with multiplication under matrices. 2 by 2 is a 4 plus 3. This is 6 plus 3, 2 plus 1, 3 plus 1. Such that this regresses to a 7, a 9, a 2, and this is a 3, sorry, with this as a 4. So sorry, yeah, so this is a 4. Yeah, you see, when mathematics becomes very sweet, yeah, you go beyond and feel like this is too simple. Yeah, so we can go to the next thing. Hope you've understood matrix multiplication. Anyway, you've not understood, you can inbox me or contact me on my private line. I'll be able to help you. So our next heading is solving equations that contain matrices. How do these equations look like? We can get an example. If we take an example such that we have a 4 1, if we have that x negative 1, we are creating an equation in matrix form. We can have here xy, then this can equal to a 4 8, and then the question is find x and y. Find, if this is that, then find x and y. So how do we find x and y using such a setting? So if we say as part of our solution, so we have here 4 1 x negative 1, we do the usual stuff we've done under matrix multiplication, the very usual stuff, and then we equate. In other words, row by column, I have here 4 times x, which is 4x, plus y, 1 times that. Then this times that, I have here x squared minus y. X squared minus y. This will equal to 4 8. So what do? I equate corresponding components. So I can say equating corresponding components. Allow me abbreviate it as that. Equating corresponding components, I have 4x plus y is equal to 4, and then x squared minus y is equal to 8. These bodies are simultaneous equations. They are pure or typical simultaneous equations, and then if we solve them simultaneously, we can eliminate y, which is the easiest to eliminate, by adding here. If I add these two guys, I get x squared plus 4x, because x squared and 4x cannot add to one thing, so this guy goes. Then this side I have there 4 plus this guy, which is a 12. I bring it to this side, I get x squared plus 4x minus 12 is equal to 0, which is a quadratic expression. So I can come, I obtain the sum, the product, and then the factors. We've done this under factorization, and then we solved a few quadratic equations in some of our videos. In case you missed and dare to look at them, they are so beautiful. So I can have there the sum is a 4, which is this one. The product is 1 times negative 12, which is negative 12. In other words, I find two numbers which when I add them I get 4, multiply them I get negative 12. So you think about those numbers. Most likely they are factors. They are factors of 12. Yeah, so numbers that can factor 12, get any two that can multiply together and then I multiply, get 12, most likely it is a 2 and a 6. But then the sum is positive, the product is negative. It means I make this birthday negative, such that when I add, I get a positive sum, multiply, I get a negative product, meaning this is negative 12 with 6. I put these ones in the position of the sum. So I have x squared minus 2x plus 6x minus 12 is equal to 0. Mathematically, I've not changed anything. When I add these two birthdays together, I go back to a positive 4x. So I do the factorization. I group these two guys together. I group these two guys together. I remove out what is common. If I group this one and this one together, what is common is an x. X into x minus 2. Then plus what is common here is a 6 into x minus 2. But what else? This and this one are common. I pull them out. I have x minus 2 pulled out. What remains behind is an x plus 6. So what I do is I equate each bracket independently to 0, such that I have x minus 2 is equal to 0, or my x plus 6 is equal to 0. X is equal to 2, or x is equal to negative 6. Yeah, so we are going to apply economics of the highest level, economics at higher level, at A level economics around, such that now we can find the values of y using any equation. We know that 4x plus y is equal to 4. So for x, 4, x is equal to 2. I put it there. So 4 times 2 is an 8 plus y is equal to 4. Take it to the other side. So my y is equal to 4 minus 8, which is a negative 4. Then 4 and x that is equal to negative 6. I put it there. So 4 times negative 6 is negative 24 plus y is equal to 4. Take it to the other side, it becomes positive. Y is equal to 28. It was as beautiful as that. Yes. So in our next video, we are doing more equations of the same nature, and then we are introducing the determinant and inverse of a matrix. So endeavor to watch it. Yeah, and subscribe to our channel, like our mathematics videos, such that we can create more interesting mathematics like this one. Thank you.